All right, this lesson is part 2 of multiplying and dividing rational expressions. We're going to start with multiplying. If I had two fractions, such as 1/2 times 6/5, let's say, what I would do is I would probably cross cancel. I could say that 2 goes into 6 3 times, and I'm left with 3/5. Or I could do it this way. 1/2 times 6/5. I'm going to factor the 6. 6 is 2 times 3. I can now cancel common factors in the numerator and the denominator. In other words, this 2 over 2 here is a 1, and so it's gone. And that also leaves me with 3/5. When we are multiplying rational expressions, the process is the same. I can cross-cancel, or I can reduce common factors in the numerator and the denominator. For example, 2r plus 4 over 5r times 3r over 5r plus 10. You have to remember, though, that everything must be factored first. Factor everything first. You can only cancel common factors in the numerator and the denominator. I can factor a 2 out of the numerator here, and leaves me with r plus 2. 5r is just 5 times r. 3r is just 3 times r. And in the denominator here, I can factor out a 5. That leaves me with r plus 2. Everything is completely factored. I can now cancel, or some books call it cross-canceling. I can get rid of the r plus 2's there, and I can get rid of those r's. Let's see what we have left. 2 times a 3, which is 6, over a 5 times a 5, which is 25. And there's my answer. Let's try another one very similar to that. 5p minus 5 over p times 3p squared over 10p minus 10. Okay, I'm going to factor everything first. I'm going to factor a 5 out of the numerator, like that. 3p squared, I can write it as 3 times p times p. And in the denominator here, I can factor out a 10. Leaves me with p minus 1. Everything is completely factored. I can now cancel any common factors that I have in the numerator and the denominator. I can get rid of the p minus 1s, and I can get rid of 1p up here with one of them down here. Oh, and I almost forgot. Look at the 5 and the 10. I could reduce that. 5 goes into 5 once. 5 goes into 10 twice. So let's see what we have left. We've got just a 3 and a p left on the top. In the denominator, all we have left is this 2 right here. So my answer is 3p over 2. All right, let's try another. Let's look at this one. K squared plus 2k minus 15 over k squared minus 4k plus 3 times k squared minus k over k squared plus k minus 20. That's a long problem. Okay, once again, I'm going to just factor everything first. This trinomial here, the two numbers that multiply to negative 15 but add up to positive 2 would be plus 5 minus 3. Down here, the two numbers that multiply to a positive 3 but add up to a negative 4 would be a minus 3 and a minus 1. This right here just has a GCF. I factor out a k. That's k times k minus 1. And finally, this trinomial will factor to k plus 5, k minus 4. All right, everything is completely factored. Let's see what we can cancel here. K minus 3's are gone. K minus 1's are gone. And this k plus 5 with that one right there. And that will leave us with a k over a k minus 4. And that's as far as it reduces. All right, let's look at this one. X minus 6 over x squared minus 12x plus 36 times x squared minus 3x minus 18 over x squared plus 7x plus 12. Okay, once again, we're going to factor everything. X minus 6 up here, nothing you can really do with that. I'm just going to leave it as x minus 6. This one down here, that will factor to x minus 6 times x minus 6. This trinomial, the two numbers that multiply to negative 18 but add up to negative 3 would be negative 6 and positive 3. And this one, that would be x plus 4, x plus 3. Everything's factored. Let's see what we can cancel. I can cancel x minus 6 over x minus 6. Now keep in mind when we cancel, really what we're doing is we're reducing this. Remember that x minus 6 over x minus 6 is actually equal to a 1. Same thing here. That over that is really a 1. Normally we don't write it in. X plus 3 over x plus 3 reduces to 1. Let's see what we have left. I got this x plus 4. A common mistake is to just write the answer as x plus 4, but notice where the x plus 4 is here. It's in the denominator. In the numerator, everything canceled away, but I'm left with a 1. So my answer is actually 1 over x plus 4. Okay, that's how we divide rational expressions. I'm sorry, that's how we multiply rational expressions. Dividing, which is what we're doing now, is basically the same thing. If you had to divide, let's say, 1/2 by 5/7, let's say, remember what we do. We flip over the second fraction like that, and it's now a multiplication problem. And then we can multiply them together and, for instance, get 7/10. It's exactly the same with rational expressions. For example, let's say we have 2z over 9 divided by 5z squared over 18. I flip over the second fraction. In other words, I multiply by the reciprocal, like that. Now we're going to cross cancel. Or if you want to show this step, this can help you avoid any errors. You could factor a couple things. For instance, I'll leave the 9 as 9, but up here I'll write the 18 as 9 times 2. And down here, that's a 5 times a z times a z. What can we cancel away? The 9's are gone, and the 1z up here will go with 1z down there. And I am left with a 2 times a 2, which is a 4, over a 5z. 4 over 5z. Here's another one like that. 16k squared over 5 divided by 3k over 10. Flip over the second fraction. That's now a 10 over 3k. Now let's factor a few things. 16 times k over 5. I'm going to write the 10 as 5 times 2 because I notice I'm going to be able to cancel 5. And a 3 times a k. I can get rid of the 5, and a k there will cancel one of those down there. And that looks like that's all that's going to reduce. So I am left with 16 times 2, which is 32k over a 3. There's my answer. One more example of dividing. Let's say we have 8k minus 16 over 3k divided by 3k minus 6 over 4k squared. Flip over the second fraction again. 8k minus 16 over 3k times the reciprocal. Now we factor everything. Oops. Hang on. Wrong color. Okay, we can factor an 8 out of the numerator there. That leaves me with k minus 2. 3 times k. 4k squared, I'll write that as 4 times k times k. And down here, I can factor out a 3, which leaves me with k minus 2. We can cancel the k minus 2's, and we can get rid of a k with that k right there. And I think that's all that's going to cancel away. We've got 8 times 4, which is 32. And in the denominator, we've got 3 times 3, which is a 9. Oh, wait a second. Forgot that k there. So I got 32k over 9. And there's my answer. And that is how we multiply and divide rational expressions.